Page 315, question number 2. We're given the fact that our rocket has a mass of 3.00 kilograms, 220 meters above the ground, and has a velocity of 165 meters per second. It's asking us what is the mechanical energy of the rocket relative to the ground. So to calculate our mechanical energy, it is equal to our kinetic energy plus our gravitational potential energy. So kinetic energy is mv squared divided by 2. Gravitational potential energy is mgh. So our mass is 3 kilograms times our velocity of 165 meters per second, all squared, divided by 2, plus our mass of 3 kilograms times gravity 9.81 meters per second squared, times our height of 220 meters. So if we can plug that all into our calculator, we will have 3 times 165 squared divided by 2 plus 3 times 9.81 times 220 meters, giving us a value of 47312.1 joules. So that will be 4.73 times 10 to the power of 4 joules of energy. Now, for part B, it asks us, when it reaches the highest point on its trajectory, what will be the gravitational potential energy? Well, at that point, our mechanical energy will be all in the form of gravitational potential energy. If the rocket goes straight up into the air, the velocity will be equal to 0 at the top, so the kinetic energy is also equal to 0. So that tells us that our gravitational potential energy will equal the mechanical energy that we just calculated, 4.73 times 10 to the power of 3 joules. Part C. If all of that energy is gravitational potential energy and we are looking for the height, we're going to have mgh. To find our height, it is going to be our gravitational potential energy divided by mg. So we're going to have 4.73 times 10 to the power of 4 joules divided by our mass, which is 3 kilograms, and gravity 9.81 meters per second squared. So putting that into the calculator, 4.73 times 10 to the power of 4 divided by 3 divided by 9.81 gives me a value of 1,607. So 1.61 times 10 to the power of 3 meters above the ground as the maximum height. Part D is asking us, what is the speed when it hits the ground? So when it gets to the bottom, all of that mechanical energy will be in the form of kinetic energy, and that's because our height is equal to 0, therefore our gravitational potential energy is equal to 0. So rearranging for velocity, it will be the square root of 2 times the energy divided by the mass. So that's going to give us 2 times our energy, 4.73 times 10 to the power of 4 joules, divided by our mass. Sorry, I'm running out of paper here. Kilograms, and we want to square root the whole thing. So on the calculator, square root 2 times 4.73 times 10 to the power of 4 divided by 3 kilograms gives me 177. So that'll round up to 178 meters per second as the speed when it hits the ground. Again, we know the direction is downwards, but because this is using energy, which is scalar, we cannot say that direction for sure. So if it's taking off, it would be going at a speed at 178 meters per second, and when it crashes into the ground, it will also be going a speed of 178 meters per second.